We've all played rhythm games at some point in our life. Whether it was on our phone, in VR or at an arcade, the experience was very similar. Friday Night Funkin', Dance Dance Revolution and Piano Tiles all follow the same concept. The player must hit notes in sync with the music. Well, in today's video I'll be making my own mobile rhythm game, but with only 1 month to do so. I immediately started brainstorming and came up with an idea. What if the game takes place in an 8-bit music player, and you are playing as the play button? I opened up a new Unity project and started working on a movement controller. To make the play button only move horizontally, I locked it on the X-axis and made it follow your finger's position. Initially, I wanted to use Unity timelines to animate the notes moving down, ensuring that the music will never go out of sync, but the process would have been very time-consuming and unorganized. So I decided to write my own song system. I created a new bitmap scriptable object that contains data like the title, BPM, audio clip, and a prefab with the notes of the song. When loading a song, the script checks if there is another song loaded. If true, it deletes the prefab and spawns in the new one, and then it updates the BPM and the rest of the data. The easiest way I found to make bitmaps was using Unity grids. With the song's BPM and some basic math, I found out how many units there were between each bit, then modified the grid, so notes placed on the grid are synced with the music. Or so I thought. I later found a big problem. Even though at the beginning everything seems fine, the smallest frame drop or bug will easily cause the music to desync. To fix this, I made the bitmap move in relation to the audio clip's time. Instead of syncing up the bitmap with the music by playing them both at the same time, the bitmap now moves based on the audio clip's time. So even if I skip forward into the song, the bitmap automatically updates to the corresponding position. I'm generating the songs using an app that converts MIDI files into 8-bit music. To keep the retro theme, I decided to mainly add songs from the 80s. All I have to do is download the song from the internet and then drop it in the app. And a few seconds later it's finished, but still not ready to be added in-game. I'll add a delay at the start of the song to leave room for the player to think. My friend messaged me saying that he's willing to work on the artwork of the game. I needed the extra time, so obviously I accepted. I then started work on the main menu. As I said, the game will take place in a music player. I added a title and artist text and a progress bar and then animated the UI elements to transition out when pressing the play button. Combined with Scarecrow's animations, the main menu quickly became more alive. In the main menu, I created a shop where you will be able to buy and select songs. I added a vertical layout group to the shop and started working on a template for the songs. It will be extremely annoying and inefficient to manually have to add songs to the shop every time I make a new one. So I created an array with all of the songs from the game and started working on a new shop manager script that spawns in a template for each song in the array. In the song scripted object, I added a price and high score variable, and a bool that tells the song manager whether the song has been purchased by the player. Now, when starting the game, you can see that the songs automatically spawn in the shop. Remember when I said that when making a new song, I have to get the BPM of the song, do some math, and then update the grid? Well, I wanted to make this procedure faster, and made a script that automatically calculates and updates the grid with the press of a button. Here's how I got stuck on the first problem of many. When I tried resuming the game after pausing it, everything would freeze. I had absolutely no idea why this was happening. I read through hundreds of forum posts and spent over 3 days struggling to fix this bug, and you won't believe how I fixed it. All I forgot to do is unpause the game after pausing it. The script set the timescale to 0 when pausing, but never back to 1 when unpausing or restarting. But no, that's not the end. After fixing the first issue, I wanted to build the game for the first time to try it on my phone. But when I did, it spat out a ton of errors saying how the Gradle build failed. I spent sleepless nights trying to fix the issue. I actually thought this was the end of the project. I downloaded countless versions of different SDKs and NDKs and Gradles, and I still have no idea what they mean. And you might be thinking that the solution was really complicated and required complex coding skills, but no. All I had to do was delete a folder that for some reason Unity installed on its own, knowing very well that it will break my game. To make the game more immersive, I added an audio visualizer at the top and at the bottom of the screen. It's time to implement a brand new mechanic, powerups. An autoplay powerup, a slow-mo powerup, and a more special reverse powerup. The autoplay one is simple. It will speed up the song while automatically hitting all the notes for a few seconds. So I set up everything in the powerup manager, and with Unity's post-processing, I created a pretty cool effect. I set up some power-up buttons and started working on a reverse power-up. This one will work a bit like Phoenix's ult from Valorant. When you activate it, you will be able to place down a node. For the next few seconds, if you die or double tap, the game will reverse back to where you placed that node. But it wasn't that simple. I wasn't actually reversing time, but had to keep count of a few factors. During that duration, all the hit notes weren't destroyed but placed in a list of notes. Then, because the bitmap moves in relation with the music, I reversed the song to the corresponding time and updated the rest of the variables. Scarecrow remade the sprite of the shop, and I added a new tab for the power-ups, and possibly skins in the future. I wanted to keep the music theme, so I made the currency of the game treble clefs. You'll find them in your bitmaps and only get them if you finish the song. I got to work on the power-up shop template and made a new scriptable object for the power-ups, and used the same method from the songs to spawn the power-ups in the shop. Some songs require a different type of note that procedurally gets shorter over time if the player stays in contact with it. I used the sprite from the default note and made it tile when resizing. And here we have the hold note. So far, the hardest thing we had to do is make the bitmaps. It's more so boring and time consuming. I gave a copy of the project to Scarecrow so he can work on some songs too. A year ago, I bought a Google developer account so I could release games on Google Play, but never had any games to release. So now I have the best opportunity to add my first game to Google Play. But first, I needed a name and a logo for the game. And what better name to give an 8-bit rhythm game than 8-bit? At this point, I needed an end screen for when you finish a song. I started working on a cool animation of the player moving across the screen and revealing your score. I made it using Unity timelines. Fun fact, when I made my first horror game 1 year ago, I didn't know about Unity timelines and had to code the entire end cutscene by hand. That's why it looks so bad. When working on bigger projects, I like to stay organized using Trello. I created a new board and invited my friend to it so we can keep track of our work, bugs and ideas. Since it was our first time making pixel art for a game, we didn't think of pixel consistency. Well, in Unity, it will be really hard to maintain that consistency, as we are working with modern technology. So my friend remade most of the art, defining the pixels and making them mostly the same size. And now is the best time to add skins to the game, like a pizza, traffic cone, and an exclusive animated Christmas tree skin that is available for a limited time. So right after this video ends, make sure to download the game and get it. I'll definitely add more skins in the future, but right now, I need this time to fix all the bugs and finish the game. Finally, I made the skin manager the same way as I made the song and power-up manager. Right now, the player looks pretty stiff, and I know exactly what it needs. Using complex physics and math formulas, I added a little sway to the player when moving him. To balance out the game, I created a spreadsheet with all of the items in the game, and how much they cost. So I balanced the game as much as I could and added a daily coin cap to the songs, so you can't just farm an easy song over and over. I also created a leveling system that is based on the sum of all of your high scores that is needed to unlock some songs and skins. AI. Everyone's talking about it, and its influence has only grown over the past couple of years. From ChatGPT writing essays to Midjourney and DALL-E 2 making realistic and cinematic images in a matter of seconds. I used all of these and still do on a daily basis, but there's one that seems way crazier. This is 11. It's a generative AI text-to-speech and voice cloning tool that can create... Like any other game, this one needed a tutorial. So I used 11 Labs AI to create a tutorial bitmap that introduces you to the base mechanics of the game. With that done, I can finally build the game and publish it on Google Play. Right now, I'm gonna take a break from the 30-day challenges to focus on some other projects. But if you enjoyed the video, feel free to leave a like and subscribe. I have more exciting content coming your way in the future.